All right. So hi, everyone. My name's Luke Kysow, and I'm the only thing between you and lunch. So today we're going to talk about migrating an application from VMs over to Kubernetes using Consul service mesh. And like I said, my name's Luke, and I'm an engineer on the Consul team. So what exactly is Consul? So it's a tool from HashiCorp. It's been around for a little while, and actually it came out probably before service meshes were a big thing. But it's always been focused on registering services, knowing where they are, and knowing what their IP addresses are. And so before service mesh came out, people started to kind of build their own homegrown service meshes on top of Consul. So at my old company, we actually used we used Consul template, we used Nginx, we built our own homegrown service mesh. Linkerd 1.0 actually used Consul for its service registry. And so as we saw the rise of Kubernetes, as we saw how service meshes have become more and more important, we decided to build our own. So the three things that I'm going to talk about today, the three features of Consul Service Mesh, are one, that it's secure by default. So all the traffic between all your pods is going to be MTLS encrypted end-to-end, and we're using spiffy identities. The other thing that we're going to talk about here is multi-platform. So HashiCorp's always been about multi-cloud and multi-platform, and Consul Service Mesh is no different. So what we're going to do today is we're actually going to connect our kube cluster to our VMs. And what we're going to do is we're going to need layer 7 traffic management to do the migration that we're going to run through. And so we'll show the config that exists in Consul Connect. So I'm Canadian, so in an effort to kind of relate to my American friends here, we're going to migrate the charger service from the San Diego data center running on a set of VMs over to our AKS data center running in Los Angeles. And what we're seeing here is the NFL service is calling the charger service, and we don't want any downtime during this migration. So this is what it's going to look like before we migrate, and this is what it's going to look like after we migrate. So here's the steps. The first step is we're going to deploy the charger service to both data centers, but we're not going to route any traffic to this charger service running in AKS because we want to test out that it's actually working as we expect. So what we're going to do is we're going to set up some L7 rules that allow us to target when a request comes with a specific header. Okay, let's route to the Azure Kubernetes cluster and not route over to VMs, but most of the production traffic will continue to route over to the charger service running in VMs. Then we're going to split things 50-50. We're going to mirror some traffic over there. So it's not mirroring, it's just 50-50 splitting. And then we're going to route 100% of the traffic over, and the migration will be complete. So I think what might be interesting here is like, okay, well, we have our Kubernetes cluster running in AKS, and we have our VMs running, they're going to be running in GCP. How does the networking all work? I'm going to get into that after the demo. All right, so here we have our Consul UI. So we have our VMs data center, which is running our chargers service and its proxy. And then we have our Azure data center, which is running the NFL service. So what I'm going to do is I'm going to go back over to the VMs data center here. I'm going to go into GCP, where I'm running my VM. And I'm going to SSH in there just to show you that actually something is running there, and this isn't all smoke and mirrors. So we're going to copy that gcloud command, bring it over to our terminal, and SSH in there. So we're using systemd to run our charger service over on the VM. So I'll show the units there. And it's running on port 8000. So when I curl localhost 8000, you'll see the response we get from the chargers service. So it says, go San Diego chargers. So super simple HTTP service. And you notice it's running on HTTP, not TLS. All right, so now if we go back over to the Consul UI and we switch over to our Azure data center, we'll see we're running the NFL service. So there's our AKS cluster running. If we go over to the kube dashboard, we look at the workloads. We'll see we have Consul running, and we have this NFL service running. So let's click through the replica sets to get to the pod here. And I just want to note a couple annotations we have here. So one is the annotation that every service mesh has, which is this connect inject annotation. So this is telling us whether we automatically inject the sidecar or not. And another annotation here, which is unique to Consul, is we're actually annotating which service our upstream is, so in this case chargers, and which port the proxy is going to listen on for routing to that service, in this case 1234, which means if we're in the container, we run curl localhost 1234, and we'll route. So here I'm copying the pod ID from the kube UI and finding out it has a trailing new line. Then I'm scrambling through my bash completion and then using another copy to actually exec into the pod properly. So when we get in there, we're just going to run curl localhost 1234, and that request is going all the way out of AKS, all the way over to GCP. And we get our expected response, go San Diego Chargers. So everything looks good over there. So now what we want to do is this first step in the migration, which it's just to deploy our Charger service into AKS. Before we do that, though, we need to set up some L7 configs. So by default, Consul is going to prefer routing to the exact same data center you're in. So if we deploy the Charger service over into AKS, immediately all the traffic would route to it, which is not what we want because we want to make sure that it's actually working over there. So what we're going to do here is we're going to create a service resolver config that's going to target the Charger service running in over a VMs cluster, and we're going to give it a new name, an alias. It's going to be chargers-VMs, and that will allow us to actually target that VM service. So you see here that the name is chargers-VMs, and that we're using this redirect config here that says, okay, route over to Chargers running in the VMs. We're going to write the identical service resolver config so we can target the Azure Charger service specifically. Now, don't freak out. This isn't YAML. Okay, it's HCL, but it's the same thing. So we're going to write this config over here, and then we're going to set up our splitter so we make sure we route 100% of the traffic to VMs so that when we deploy our service over into Kubernetes, we're not going to get any traffic routing to it unexpectedly. We want to test that it's actually working and running as we expect in Kubernetes. So we're going to write that config there, Consul config write service-splitter. All right, so before we deploy, we're going to set up a curl running in a loop just so we can be sure that the traffic isn't doing anything weird. So here we are, we're running, and we're just grepping for that body there, so we only get that part of the response. So now we're ready to deploy our service to Kubernetes. It's a normal deployment. The only difference is that we have this annotation here, which says to inject our sidecar. And we're changing the message because now we're running in the LA data center, so it's going to be go LA Chargers. That way we'll be able to tell which one we're routing to. So let's run kubectl apply-f and deploy that service into Kubernetes. When we list the pods, we'll see that it actually has 2 containers. That's because we're adding our sidecar as expected. And it says it's a little bit small, kubectl to get pod grep charger. We see it's got 0 to 2 containers, and when we do it again, we'll see it's fully up and running. But when we switch back over to our terminal here, we'll see that nothing's changed. We're still routing to our VM service, so our L7 config there worked as expected. All right, so we got Chargers running in Kubernetes. Let's actually route to it and see if it's actually working as expected. So we're going to create a new config here, and we're going to target the Charger service. And when we see a header that's x-data center, and the value is Azure, we're going to route to our Chargers-Azure service. Remember, that's the one running in the AKS cluster. So let's write this config, Consul config write, and I think I called it service-router. All right, so now we're going to open up a new terminal window, and we're going to curl with that header. So open up a new terminal window. We're going to find the NFL pod again. We're going to kubectl exec into that NFL pod, and then we're going to run curl-h x-data center :Azure. So we're going to add this header here, and we should see the response from the AKS for the service running in AKS, which has a different body. And we see it says go LA Chargers. So that's the L7 config working. You can imagine running this for a while, testing this out with different headers, running some canary traffic through it. But unlike Sven was saying in Google, you got to go slow, slow, slow. We have 10 minutes left in this lightning talk, so we're going to go fast. So 50% of our traffic sounds about right for our first step in a migration after testing it for 2 seconds. So 50% of our traffic is going to go over here to our Azure service. We're going to apply this splitter, and immediately my connection is going to drop. So we're going to have to restart that curl over there as I wait. OK, let's do that again. When we get back in there, we'll see that 50% of our traffic is randomly load balancing between the Charger service and LA Chargers in VMs. So that looks good. I've looked at about 10 responses, and that's enough for me. So we're going to route 100% of that traffic now to our service running in Kubernetes. So we're going to change that to 100, and that to 0. And we're going to run Consul config write service-splitter. And we should see all of our traffic now routing to the LA Chargers service. And our migration is complete. And it took 6 minutes. So how did that all work? That was kind of cool. Like when the charger service was running in AKS, it was like, okay, cool, you're routing between 2 pods of Kubernetes. That's not that interesting. But when it was running in AKS and when it was running all the way in VMs, like what was going on there? That was kind of a little bit magic. So what we did was we deployed a Consul server cluster in our VMs. And then we used our Consul Helm chart to deploy our Consul server cluster in Kubernetes. And we federated the two of them. So now they're talking to each other. They know about which services exist where. Then we deploy our mesh gateways at the edge. So in the VMs, this is another binary. You just need Consul and you have Envoy. And in Kubernetes, you just use the Helm chart. And so these mesh gateways are going to be using a load balancer. And so they're actually going to have public IPs because we need to route across the internet. That's dangerous. We'll get into that later. So we add our sidecars. Everyone loves sidecars. And so the request path here is the NFL service hits localhost 1234. That's going to go through the Envoy sidecar. That's going to get TLS encrypted with its spiffy identity, routes to the mesh gateway in the AKS cluster, out over the public internet. That's okay though. It's TLS encrypted into our mesh gateway running our VMs, over into the sidecar running on the VMs, and into the charger service. And you see here it's unencrypted, so that's just getting it over pure HTTP. Cool, so that was kind of cool. We just did a migration from VMs all the way over into Kubernetes. You can imagine that you're probably not going to be migrating everything. We're going to be kind of in a multi-platform world for a long time. And so it's really useful to be able to route between things and use the same service mesh we like to use in Kubernetes across all of our other platforms. Okay, but what about Kubernetes to Kubernetes? Well, unfortunately, I don't have time to show you that because we're about to have lunch. But suffice to say, it's as simple as switching your kube config to your second context. For instance, if you were migrating the charger service to London, and you run helm install, and you get up and running in Kubernetes. All right, so like I said, it was a lightning talk. We didn't have a lot to cover. So some things that are worth talking to me about, or maybe come to the booth and talk to us about, you can install with Helm, and obviously there's a ton of different options there, lots of different ways you can configure things. We didn't talk about our integration with different observability, so Prometheus and Datadog, you can send your Envoy metrics over there. We also didn't talk about intentions, so how was the NFL service even allowed to talk to the charger service? So that's kind of like network policy. We use service identity to allow the request to go over there. And also, we didn't talk about how we can integrate with external certificate authorities. So the TLS you saw there was all done using Consul. It's super cool, like 3-day certs. We do cross-signing and rotation for you. But if you want to use an external certificate authority, you can use Vault. We're soon going to release an integration with AWS, PCA. So lots of stuff to cover. Unfortunately, I didn't have time. Please come grab me. I'll be here for the whole KubeCon. My name is Luke Kysow, at lkysow on Twitter, and thanks a lot.